Imagine standing on the deck of a giant submarine. Within seconds, the massive steel machine begins to disappear beneath the ocean. Slowly, the waves close above it, sunlight fades, darkness grows hundreds of meters below the surface. The pressure becomes enormous, enough to crush almost anything. Yet, inside the submarine, people walk normally. The lights stay on, the air is perfectly breathable, and the submarine continues moving silently through the deep ocean. Here's the biggest mystery: a submarine can weigh thousands of tons, so why doesn't it sink forever? And once it dives, how does it return safely to the surface? Is it using giant engines, hidden propellers, or something far more surprising? The answer lies inside one of the greatest engineering inventions ever created. Today, we're diving deep into the world of submarines to discover how they dive, how they float, how they survive extreme underwater pressure, and why these incredible machines can remain hidden beneath the ocean for months. Before we understand how a submarine dives, we first need to answer a much bigger question: how can a machine made almost entirely of steel float at all? After all, steel is heavy. Drop a solid block of steel into the ocean and it sinks immediately. So why doesn't a submarine do the same? The answer comes from a simple law of physics called Archimedes' principle. It says if an object pushes aside enough water, the water pushes back with an equal force. This upward force is called buoyancy. Think about a large ship. It weighs thousands of tons, yet it floats not because steel floats, but because its huge hollow shape displaces an enormous amount of water. A submarine uses exactly the same idea. Inside its massive steel body are large empty spaces. These spaces reduce its overall density, allowing it to float on the ocean's surface. But here's where submarines become truly amazing. Unlike a ship, a submarine can change its own buoyancy whenever it wants. It can float, sink, or stay perfectly balanced at any depth without touching the ocean floor. This incredible ability is made possible by one of the smartest engineering systems ever designed, something called ballast tanks. Ballast tanks are the reason a submarine can disappear beneath the ocean whenever it wants. These giant tanks are built inside the submarine, running along both sides of the hull. When the submarine is floating, the ballast tanks are mostly filled with air. This keeps the submarine light enough to stay on the surface. But when the crew decides to dive, everything changes. Large valves open automatically. Seawater rushes into the ballast tanks. At the same time, the air inside is pushed out as more water fills the tanks. The submarine becomes heavier. Its buoyancy gradually decreases until the upward force and the downward weight are no longer equal. Slowly, the submarine begins to sink, not because its engines pull it downward, but because its own weight has increased. Yet the dive remains completely controlled. Engineers can fill only part of the ballast tanks. This allows the submarine to stop at almost any depth, neither sinking nor rising. It simply floats underwater almost. This when it's time to return to the surface, the process works in reverse. Powerful compressed air is released into the ballast tanks. The air pushes the seawater back out into the ocean. As the water leaves, the submarine becomes lighter. Its buoyancy increases again, and slowly the giant vessel rises back toward the sunlight. No magic, no hidden technology, just brilliant engineering and the perfect balance between air, water, and weight. Diving underwater creates another serious problem: pressure. The deeper a submarine goes, the greater the water pressure becomes. At just 10 meters below the surface, the pressure has already doubled. At hundreds of meters deep, the force becomes almost unimaginable. Every square centimeter of the submarine is being squeezed from every direction, enough force to crush an ordinary vehicle within seconds. So how does a submarine survive? The answer lies inside its pressure hull. Unlike the outer shell, the pressure hull is the real protective structure. It is built using extremely strong steel, or in some submarines, advanced titanium alloys. Its walls are incredibly thick, much thicker than most people imagine, but strength alone isn't enough. Engineers also give the pressure hull a rounded shape. Why? Because a curved surface spreads pressure evenly instead of allowing the force to concentrate in one weak point. This is why most submarines have a long, rounded body rather than sharp corners inside the pressure hull. The crew feels almost normal air pressure even while the ocean outside is trying to crush the submarine. Without this incredible design, deep-sea missions would be impossible. The pressure hull isn't just part of the submarine, it is the reason the people inside can safely explore one of the most extreme environments on Earth. Now imagine living inside submarine for weeks or even months deep beneath the ocean. No fresh air, no open windows, no trees. So how do the crew keep breathing? The answer is another engineering masterpiece inside every modern submarine. Powerful life support systems work 24 hours a day. Every breath the crew exhales contains carbon dioxide. If this gas continued building up, the air would soon become dangerous. To prevent this, special machines continuously remove carbon dioxide from the air using advanced chemical filters. But removing carbon dioxide is only half the solution. The crew still needs fresh oxygen. Some submarines carry large supplies of compressed oxygen, but nuclear submarines can do something even more amazing. They produce their own oxygen using electricity to split water into hydrogen and oxygen. This process is called electrolysis. The oxygen is released back into the submarine while the hydrogen is safely removed. The air is also cleaned to remove moisture, dust, smoke, and other tiny particles. Powerful filters keep the atmosphere fresh and safe inside the submarine. The crew can breathe almost as comfortably as they would on land. Without these life support systems, a submarine could never remain hidden underwater for weeks or months. It's not just the engines that keep a submarine alive. It's the invisible systems quietly working every second to keep every person on board alive. Deep beneath the ocean, there is almost no sunlight. The deeper a submarine travels, darker everything becomes. At great depths, a crew member cannot simply look through a window to see what's ahead. So how does a submarine navigate safely? The answer is sound. Instead of using light, submarines use a remarkable technology called sonar. Sonar means sound navigation and ranging. Here's how it works. The submarine sends out a powerful sound wave into the water. The sound travels until it hits an object, a mountain, another submarine, ship, or even the ocean floor. The sound then bounces back. Sensitive receivers inside the submarine capture the echo. Powerful computers measure how long the sound took to return. Using this information, the system calculates the exact distance and location of nearby objects. It's almost like echolocation, the same technique used by bats and dolphins. Modern submarines use extremely advanced sonar systems. They can detect ships, underwater obstacles, sometimes even other submarines many kilometers away. But there's another challenge. A submarine must also avoid being detected. That's why military submarines often travel as quietly as possible. Their engines are specially designed to reduce noise. Their propellers are shaped to create very little vibration. Every sound inside the submarine is carefully controlled because underwater noise can reveal its position in the silent world beneath the ocean. The submarine doesn't depend on its eyes, it depends on its ears. So how do submarines stay underwater? The answer isn't one amazing invention, it's the combination of many brilliant engineering ideas. Ballast tanks control buoyancy. The pressure hull protects the crew from crushing ocean pressure. Life support systems create fresh air for months. Sonar allows submarines to navigate in complete darkness, and powerful engines carry these giant machines across the oceans without ever being seen. The next time you hear the word submarine, remember this: you're not looking at just a military vessel, you're looking at one of the greatest engineering achievements ever created, a machine that can carry dozens of people hundreds of meters below the surface. Where sunlight disappears, pressure becomes deadly, and survival depends entirely on science, engineering, and human innovation, modern submarines don't simply travel underwater, they create a safe world inside one of the most hostile environments on Earth, and that is what makes submarines so extraordinary. If you enjoyed this documentary, don't forget to like, share and subscribe to *RailForge*, because here we explore the incredible engineering behind mega machines, modern technology, and the inventions that shape our world. Thanks for watching, and we'll see you in the next documentary.